Chapter 4. Exploring Data with Graphs. Today we draw graphs. R is widely praised for its graphing capabilities. Good figures are crucial for data analysis and for your papers. No pressure. Aims for this session. Our goals are: learn how to present data clearly, get a quick introduction to ggplot2, and practice essential plots, scatterplots, histograms, boxplots, and error bars. All of these are genuinely useful. What makes a good graph? Here are some basic rules. 1. Show the data. 2. Make the reader think about the data, not about decorative gadgets. 3. Do not distort the data. 4. Maximize the data-to-ink ratio. Present many values with minimal non-essential ink. 5. Keep large data sets coherent if you have them. 6. Invite meaningful comparison across groups, treatments, or time. 7. Make the data unmistakably clear. A polite way of saying, be honest and simple. Let's critique a graph. Why is this graph bad? Take a look at this silo-style chart. What is wrong with it? Pause for a moment and think. Doing your own diagnosis matters. Textbook answers. 1. 3D effects do not add information and make values harder to judge. 2. Textures and patterns are unnecessary. They look fancy but distract from the data. 3. Cylindrical bars are pure decoration and obscure comparisons. 4. Unclear y-axis label. What does number actually mean? Labels must be explicit. Why this improved version is better? Think for a moment, then compare. Textbook answers. 1. 2D plot. The unnecessary third dimension is gone. Comparing treatments and behaviors is much easier. 2. Informative y-axis. The label now states the measure clearly, e.g., number of obsessions per day. 3. Fewer visual distractions. Patterns and 3D shapes are removed. 4. Less ink, more signal. Simplified axes and light reference lines keep attention on the data. Please do not deceive the reader. Which plot is better, the left or the right? The left plot uses a y-axis scaled to the natural maximum, giving a fair impression. Here, eating cheese before bed appears to increase nightmares. Sorry, cheese lovers. Now imagine you are the minister of cheese. You want the opposite impression. Easy. Stretch the y-axis far above the means so the difference looks tiny. That is the right plot. See the trick? Same data, different story. Please choose honesty over ministerial creativity. A few suspicious styles we sometimes see. Left. Bars with 3D effects looks dramatic, proves little. Middle y-axis cut at 80% makes small changes look huge. Right. Artistic graphics where picture size does not match the numbers. Nice poster, weak evidence. Let's draw our own graphs. We will use ggplot2, which is part of the tidyverse. First, install and load as shown on the slide. Let's revisit our goal here, to plot various graphs using ggplot2. So what exactly is ggplot2? ggplot2 is one of the most representative packages in R, was created by Hadley Wickham, often called an R legend. He is chief scientist at POSIT and leads the Tidyverse team. When your plot looks good, you can thank him. When it does not, check your code. How ggplot2 thinks: layers, geoms, and aesthetics. When you define a layer, you specify what to draw with a geom: points, lines, bars, text, and so on. Each geom has aesthetic properties, position, and appearance, set with AIs through AES. You control color, size, line type, shape, and mapping to variables. Add layers to build the figure. Systematic, repeatable, and clear. The structure in practice: geom, the geometric object, bar, point, line, text. AES, mappings that control where and how things appear. X, Y, color, size, shape. You can set AOS globally for the whole plot or locally for specific geoms. This systematic design is a big reason R graphics, especially with ggplot2, stand out. There are many geoms. There are lots of geoms, too many for one slide. You can check the details at the ggplot2 reference site. In practice, we most often use geom bar, geom point, and geom boxplot. Let's start with web data you can copy and run. When images are hard to imagine, the best cure is to make a lot of plots. Feel free to copy-paste the code and watch it work. My favorite starter is the Penguins dataset. Install and load it like this. Install .packages, Palmer Penguins, library, Palmer Penguins library ggplot2, data penguins. Meet the species. This dataset includes chinstrap, Gen2, and Adelie penguins. Which species do you think has the longest bill on average? Take a guess first. Predicting before plotting is a healthy habit. A histogram of bill length. Let's draw a histogram of bill length in millimeters. ggplot penguins, ANSX equals bill length, geom howdy histogram, GG title histogram of penguin, bill length, tip, in ggplot, put plus at the end of the line. The most common mistake is to break the line without plus R will run early and the plot fails or only half draws. Do not begin a new line with plus and keep plus at the end of the previous line. A box plot by species. Now a box plot comparing species. ggplot data equals penguins, AES, X equals species, Y equals bill length, millimeters, fill equals species plus geom or box plot, plus labs title equals box plot. How does it look? Starting to feel doable. Let us return to the textbook dataset and try it with our own data. Title, anxiety, and exam performance of participants, 103 students. Measures time spent revising in hours. Exam performance in percent. Exam anxiety, also called EAQ score out of 100 gender. Here is the kind of code we will use. What does this command mean? Idea: we build a scatter object with ggplot using exam data. We set the x-axis to anxiety. We set the y-axis to exam. Then we add a point layer to draw a scatter plot. Labs sets the axis titles. Here is the color map for the code parts. Yellow shows which data set we use. That is the data source. Green is AES, the mapping. Here we map anxiety to the x-axis and exam to the y-axis. Light blue is the geom, the drawing layer. Here we use geom point, so it is a scatter plot. Navy is labs for axis titles. The x-axis title is exam anxiety. The y-axis title is exam performance. Please use the colors as little hints. Scatterplots can also show a smooth trend line. Light blue is GM point, add GM smooth to draw a line. If you do not set any method, the line is chosen automatically low S, means locally weighted regression. This is a non-parametric method. LLM means a straight line from linear regression. This is the simplest baseline. If you do not have any prior knowledge, we recommend that you start with LM. Now let us compare male and female groups. Set color to gender inside the mapping alpha controls transparency. Closer to 1 means darker. Here is the result. It is easier to understand when we view it with different colors like this. Men's exam performance was more negatively affected by anxiety than women's performance. This slide shows a paper by Professor Cato in our department. It studies water stress and grain yield. Water stress is a strong predictor of yield loss. Nutrient additions raise the level of the response, but do not remove the negative effect of increasing stress. A scatter plot with a fitted line is central even in natural science papers. Next is the histogram. Histogram reveals shape skewness, kurtosis spread, and unusual scores. It is a fast health check for a variable. We use the dataset named Download Festival DAT. Biologists were worried about possible health effects of a music festival. Hygiene was measured across 3 days for 810 audience members. The measure used a standardized method. The score ranges from 0 to 4. 0 means you smell like a corpse rotting up a skunk's arse. 4 means you smell of sweet roses on a fresh spring day. Let us draw a histogram for scores on day 1. Same color rules. Yellow is data, green is AES. It maps your table columns to what you see on the plot. Note, the textbook uses an option named OPTS. That option is deprecated in current ggplot. Use theme instead. First, create a plot object named Festival Histogram. Use festival data as the data source and map day 1 to the x-axis in the aesthetics. Then we apply a theme and set legend position to none. Add a histogram layer to festival histogram. Use a bin width of 0.4. Set an x-axis label to hygiene using labs. This turns the figure into a proper histogram. Here's the figure. It looks left heavy. Why is that? Is it a political stance? What do you notice? Yes, there is a single outlier on the right to show that value the scale expands and many bars appear left heavy. An outlier is a score very far from the others. It can pull the mean and inflate the standard deviation. Detecting outliers is one key goal of histograms. In this case, a value of 20 is strange because the hygiene scale is 0 to 4. Next continues to the histogram. Let us learn box plots, also called box and whisker diagrams. A box plot has a box and 2 whiskers. The box shows the median, the upper quartile, the lower quartile, and the middle 50% range. The whiskers show the range and the outer 25% limits above and below. Here's how to build a box plot for day 1 by gender. Set dataset to festival data. Map gender to the x-axis. Map day 1 to the y-axis. Use a box plot layer as the geom yellow is data. Green is AES, mapping light blue is the geom. Here is the result. We see separate box plots for men and for women. The outlier detected by the histogram now appears as a dot. In this case, it belongs to the female group. When you find an outlier, think carefully about rules for exclusion. If you drop a sample, use clear criteria based on the measurement scale and document the rule. Arbitrary deletion is data fabrication, and that is the path to the dark side of data science. Here is how to drop samples with a clear rule. Create a new data set named Festival Data Filtered. Filter records where day 1 is strictly less than 4 because the scale maximum is 4. In some research, the mean plus or minus 3 standard error is used for data filtering. We'll then repeat the plotting using the filtered data set. Only the yellow data reference changes to the filtered name. Now the figure is much easier to read. Bad values can hide patterns in figures and in statistical models. Accurate measurement and careful data cleaning are essential. For sushi, good fish needs clean scales and clean blood. Good analysis needs clean data like sushi. Interpretation for box plots. The lower whisker end is the minimum score. The upper whisker end is the maximum score. The box marks the central 50%. Lines show the median, the upper quartile, and the lower quartile. It is a compact plot with lots of information. Like good sushi, small in size but packed with flavor. Here is an example that uses box plots in economic valuation. It shows willingness to pay for environmental conservation. Box plots are easy to read and very informative. They are used across many academic fields. Here is a simple visual comparison. Which project has higher willingness to pay? Dune Headland. Seawall box plots make this easy to compare. Finally, bar charts and error bars. A bar chart usually shows a mean. Error bars stick out like whiskers from the bars. They can show 3 kinds of precision, confidence intervals, usually 95%, standard deviation, standard error of the mean. Dataset description for this example. Do female-oriented movies exist? Participants male 20 and female 20. Half of each group watched one of 2 films. One film was Bridget Jones's Diary, which is often called a female-oriented movie. Most procedures are same as before. Load the data and set axes in the mapping. Choose the x-axis and the y-axis with AES. Then add the layers. Note about function names. The textbook shows fun.y. That option is deprecated in ggplot2. Use a summary layer that draws bars based on summary statistics. Set fun to mean to make the bar display the mean value. Set stat summary with fun data set to mean _CL _normal. And the geom set to point range to show the mean and its confidence interval. This draws a bar from summary data and adds the interval. Here is the result, simple and clear. The vertical lines also show the confidence intervals. Now split by gender and switch the layer to error bar. Set width to 0.2, so the bars are slimmer. This makes the error bars 20% of the bar width. Here is the code layout to read. You should now be able to follow it. Read each part and learn which option controls which feature. Here's the new result. Error bar is often clearer than a bar with a cap. The width is 20% as said earlier. Here is a fuller example split by gender with more styling. Red part sets fun to mean with a bar layer to show the mean. Pink part sets fun data to mean _CL _normal with an error bar layer to show the confidence interval Purple part splits the plot by gender. Blue-green part uses labs to set axis labels. Green part sets a theme to hide the legend. Here's the result. The panels are separated by gender. Let us also change colors. Can you read what each part is doing? Adding line breaks and short comments makes the code easier to follow. Take your time and map each line to the visual change. Here is the final result, colorful and now with a legend. You can see a similar use in a paper by Professor Cato. The topic is the rice ratoon rice system called RRR. Can yields be maintained without replanting by letting plants regrow? That could reduce costs and labor. The figure suggests yields are a bit lower than for hybrid rice and some other systems. Therefore, it is probably difficult for farmers to rely solely on RRR. This slide is skipped. Please jump to the last slide. Homework for this lecture is here. Details and deadlines will be posted on UTOL. Please check UTOL for submission.